Hi guys, we're going to start on page 10 and we're going to review trig functions and then prove the other 4 trig functions which you don't know. And before we do that, we need to know what the chain rule is. So when I was pregnant with my first daughter, I remember coming across this little cartoon and thinking, oh, it just speaks to me so well. And since then, I've always taught chain rule this way. It sounds kind of weird at first, but every problem that we do, we kind of go over it in terms of who's the mommy, who's the baby. So the chain rule is used to apply a derivative to a composite function. And a composite function is one where you have a function within another function. And so the inside function is the baby, and the outside function is the mommy. So, when you learned of it, it was like f of g of x. Well, the g of x would be considered the baby, and the f of x would be considered the mommy. So the rule is you differentiate the mother and you leave the baby inside, leave it alone. So meaning take the derivative of the outside function, you leave the baby alone, you leave the inside function alone, and then you times it by the derivative of the baby. And I know it sounds really strange, but it does help to have students see, kind of almost like physically see the inside function as the baby. So the strange ones get to be the ones where you have multi-generational, so more than 2 generations. So let's start with a review, a quick refresher. The derivatives that you learned from the Khan Academy videos and ones that I've mentioned so far is that the derivative of sine is cosine of x. So that's one that you'll have memorized hopefully by now. The derivative of g of x is negative sine of x. So another one that you should have memorized. And now tangent of x we're going to memorize eventually, but just in case you ever forget, I'm going to derive it for you. Tangent of x is the quotient of sine of x over cosine of x. So when I'm taking the derivative of this, I'm going to remember that I can rewrite it as sine of x over cosine of x and use quotient rule from there. F prime of x is low d high. Low, the derivative of high, the sine of x is cosine of x, minus high, which is sine of x, times the derivative of the low, which is negative sine of x, all over what's below squared. So cosine of x quantity squared. So we end up with cosine squared of x plus sine squared of x, which hopefully you recognize to be Pythagorean identity, just 1. And then so we end up with 1 over cosine squared of x, which eventually leads me to the fact that the derivative is equal to, of tangent of x is equal to secant squared of x. So that's our third one. And then with secant of x, if I kind of think of it in the same way, secant of x is 1 over cosine of x. Now I can most certainly use my quotient rule here, but I'm going to show you guys how we would apply the chain rule with this first one. Okay, so 1 over cosine of x, do we agree that we can also write that as cosine of x to the negative 1? And so to help us out with the chain rule, I'm going to color code 2 things. Pink is going to be the mommy function, and blue is going to be the baby function. So pink is mommy, and blue is baby. So in this expression, cosine of x to the negative 1, the baby function is cosine of x, and the mommy function is the negative 1. So we take the derivative of the power part first. So g prime of x is equal to negative 1, bring the negative 1 down, times, not times, but times, negative 1 times cosine of x. So we leave the baby alone, and then we continue with the power rule. So minus 1 to negative 1 is negative 2, times the derivative of the baby function, which in this case is negative sine of x. So once again, take the derivative of the mommy function, leave the baby alone. So take the derivative of the mommy function, leave the baby alone, and then times the derivative of the baby function, which is the derivative of cosine is negative sine of x. And normally I would tell you guys to just leave it, but we're actually trying to prove what the derivative of secant of x is. So from there, we're going to rewrite it. The negative times the negative is positive, So we have a 1 over cosine of x, and what I'm going to do is change it so that it's the product of 1 over cosine of x times sine of x over cosine of x. And does everyone agree that says the same thing as the above? You have sine of x on top and cosine squared on the bottom. The reason why I did that is because 1 over cosine of x is secant of x, and sine of x over cosine of x is tangent of x. So our derivative for secant of x is equal to secant of x itself times tangent of x. And so we can apply the same strategy for proving cosecant of x by changing it to 1 over sine of x. And what we find is that its derivative looks really, really similar to that of secant of x. But instead of secant of x, it's itself negative cosecant of x, and then times, instead of tangent, cotangent of x, which is kind of neat because it makes for remembering it much easier. And then again, we can find the derivative of cotangent of x. By the way, this is supposed to be cotangent of x, so if you guys can change that to say cotangent of x, we're trying to prove that. The derivative of cotangent of x, we can do the same thing and change it to cosine over sine and apply the quotient rule, and guess what? It's going to be really similar to what we got for tangent of x. The derivative of tangent of x is secant squared. So g prime of x for cotangent of x is cosecant squared of x, but guess what? It's negative. One thing I want you guys to notice, all three trig functions that start with a c, so look at cosine of x, look at cosecant of x, and look at cotangent of x. Their derivatives all have a negative in front of it. So you're going to remember that of the 6 trig functions, the 3 that end up with a negative derivative are ones that start with the letter